Hello Longhorns, this is the Algebra 2 Pre-AP Test 1.1 review. Good luck. I won't be going through every single question on the review for this video, but I will be covering some of the questions that I feel are the most important that you should focus on to prepare for the test. Alright, in this problem we are evaluating this function when the input is -6. So what this means right here, which you should have realized by now by doing all your work, is that we're substituting all of the variable a with a -6. So we're just plugging -6 into the function. So 3 times -6 squared minus 1. So I want you to be careful right here. This 3 is not squared. Only the -6 is squared. Also be careful with this negative sign. -6 squared is not -36, it is 36. It's positive. So 3 times 36 minus 1 gives us 107. Now we're moving on to question 3. All right, so for question 3, we have this function operation, which is h minus g of 1. That means I'm going to be subtracting these functions after or before I substitute the 1. So we're going to be substituting 1 into these functions. So there's two ways we can do this. And the first way I did this, I substituted the 1 into the functions first. So here I've substituted the 1 into the function. I got a 3 here for h, and I got a -2 for g. And then I did the operation h minus g. So 3 minus a -2 is the same thing as plus 2 is 5. Now over here, I did the function operation first, and then I substituted in the 1. So here I have 3 of x, or 3x, minus this function, which is 2x minus 4. So if you do it this way, make sure that you put the function that you're subtracting in parentheses. If you don't, then you're going to get it wrong because of this negative sign. Since we're subtracting right here, you have to put whatever comes after that subtraction into parentheses, or you're going to get it wrong. All right, so here we have 3x minus 2x plus 4. This simplifies to x, so then we just substitute our 1 in for x, and we get 1 plus 4 is 5. So you can see either way we get the same solution. So this could be a good way to check your work if you have time, but don't ponder too much on this because you have 15 questions to answer on the test, and you may not have time to do both ways. So if you have time to go back and check your work, please do that. Otherwise, just pick one of the methods to do and do that. Okay, similar question for question 4, except this time we're adding the functions. Okay, so here you can see I did it both ways again. You just choose the one you think is better for you, and that's all good. So here we've substituted the 2 in to the function first. So 2 squared plus 4 is 8. We substituted the 2 into this function. 2 times 2 is 4 minus 4 is 0. And then it says to add the functions together. So g plus f is 8 plus 0, which gives us 8. Over here, I did the function combination first, x squared plus 4 plus. And I went ahead and put this in parentheses, even though it's really not necessary since this is a plus sign. But I did it anyway just for consistency. So we get x squared plus 2x, and then 4 minus 4 is 0. So then we substitute the 2 in right here. 2 squared is 4, plus 4 is 8. So 4 plus 4 is 8. All right, so in question 5, it is another function operations composition or combination problem. This time we are substituting in a -4x. Instead of just a number, now we have another variable. So we're substituting in a term that has a -4 times a variable in it in for x. So in this first one, again, we're substituting first and then combining. Over here, we combined and then substituted. Either way, whichever way is your favorite, that's the one you're going to do on the test. Okay, so let's do it the first way. We substitute a -4x into this function right here first. And when we do that, we get -64x to the third plus 16x. Why is it plus 16? Because this is a negative 4 times a negative 4x, which gives us a positive. So don't forget that. Watch out for this guy right here. All right, so then we're going to do the same thing with this function, which is x minus 3. So we just plug in the negative 4x where the x is, and then we have a minus 3. Now the operation says to subtract them. So g minus f, again, another negative. Watch out for these guys. So we have negative 64x to the third plus 16x, which is what we got here, minus, however, for the test, you only need to pick one of those methods to do for the test. Okay, another function operation, this time multiplication. Okay, so for this problem, we're multiplying this time. So in the first example, I substituted in the negative 5 first. So here we have negative 5 plus 2 is negative 3 for g of negative 5. For h of negative 5, we have 2 times a negative 5 squared minus a negative 5, which gives us 2 times 25. Remember, when you square negative, it's positive. Then minus a negative 5 is the same thing as plus 5, so we get 55 right here. And then we multiply them together. That's what g times h says, multiply them together. So negative 3 times 55 is negative 165. Now over here, I multiplied the two functions together first and then substituted. So if you're going to do it this way, make sure you use FOIL or box or whatever method it was that you learned how to multiply binomials together with in Algebra 1. In this case, I just used FOIL because I felt it was a quicker, easier way to do it this time. 2t times 2t squared is 2t to the third. Outside times outside, I get t times a negative t squared. Inside times inside is 4t squared. And then outside times outside is negative 2t. Then I substituted my negative 5 in after I simplified this. So I simplified this down to 2t to the third plus 3t squared minus 2t and substituted in the negative 5. After I substituted in the negative 5, I got negative 250 plus 75 plus 10, and that still gives me a negative 165. So pick which method is your favorite and do that for the test. Okay, here we have a function composition problem. So what I want to emphasize here is the g of f is the same thing. This right here does not mean multiply. Make sure that you understand the difference between this open circle, which means g of f, and the multiply sign, which is a solid dot. Okay, this is not a solid dot. This is of g of f. It can also be written as g of f of negative 6. You might see it also written like that on the test. So be aware of what this means. This means that I'm going to take my negative 6, I'm going to plug it into my function f first. So I'm going to plug it into f first, and then I'm going to take that number, whatever it is, and then I'm going to plug that into g. So just make sure that you understand what this annotation means, g of f. It means I'm going to plug something into f, and then I'm going to take whatever that is, and I'm going to plug it into g. Okay, once again, we have two ways to do this. You can do the substitution of the number into the functions first, and then do the combination, or you can do the composition, and then you can do the composition and plug it in. So it just depends on which is your favorite. Okay, so if we plug in the 6 first, we have f of negative 6. We have to plug that in first. So if we're plugging in the negative 6 into f first, we have f of negative 6 equals 4 times a negative 6 minus 3, which is a negative 27. Then we're going to take that number and plug it into g. That's what f of g means. So I'm going to take this number right here that I got from f of negative 6, and I'm going to plug that into g. So g of negative 27, this is g right here, 3a minus 5. I'm going to plug that negative 27 in for a, and I get 3 times a negative 27 minus 5, which gives me a negative 86. Or you can do the function composition first, which means you're going to take this g function, you're going to plug f into g, which all that means is I'm going to take this a right here and I'm going to open it up. I make us big parentheses right here so I could stick this function inside. And I put that function in there. I've got 4a minus 3. And then we have a minus 5 here on the end. There's my minus 5 right there. So I have to distribute the 3. So 3 times 4a is 12a. And 3 times a negative 3 is negative 9. I combine like terms and I get 12a minus 14. Then I plug in my negative 6. So 12 times a negative 6 minus 14 is negative 86. So you can do it either way. The preferred way is to do it this way because that's the way you're going to have to do it in pre-cal. So you might as well get used to it. Function combination means that you're going to, composition, I'm sorry. Function composition means you're going to plug one function into another. So that's exactly what we've done here. So question 12 is another example of this, f of g of negative 1. All right, so here we have another function composition problem, and so we've plugged in the negative 1 into g first. So I've taken this negative 1, I've plugged it into function g. That's what it says to do here. We're going to do this first. So negative 1 into g gives me negative 1 squared, which is 1. 1 minus 5 is negative 4. So my g of negative 1 is negative 4. Then I'm going to take that number and plug it into f. So into f, I'm plugging in what I got for g of negative 1. G of negative 1 is negative 4, so I plug that into f, and I get 2 times a negative 1 plus 4. So 2 times a negative 4 plus 4. So you're plugging in the negative 4 into f. So 2 times a negative 4 plus 4, that's negative 8 plus 4, which is negative 4. Over here we do the function composition or composition first. We're taking the 2x squared minus 5 and we'll plug it in to 2x plus 4 first. So this is what I'm showing you right here. You take this x, open it up, make a big parenthesis out of it, then you're going to plug this into it. So x squared minus 5 goes in here. So that gives us, and after I do my distribution, 2 times x squared is 2x squared, and then 2 times a negative 5 is a negative 10 plus 4. When I simplify this, I get 2x squared minus 6. Now I'm going to plug in my negative 1. Negative 1 goes into the new function. Negative 1 squared is 1. 1 times 2 is 2. 2 minus 6 is negative 4. So I still get the same number that I got over here. Pick which method you like. This one is better for pre-cal, so if you're thinking about the future, you might want to start working on this method. All right, so for question 13, we have another function composition. This time I'm plugging in the negative 3 into h first, and then I'm going to take that function and plug it into g. So here you can see I plugged in the negative 3n for h into function h, and I get negative 12n plus 3. Now I'm going to take that function and plug it into g. So you can see I've plugged it into g right here. This g is 2n plus 2. So I've taken this n and replaced it with a negative 12n plus 3. Then I simplify this and I get negative 24n plus 6 plus 2, which is negative 24n plus 8. And that's my final answer. Now I do the same thing the other way. If you want to do the function composition first, you take function h, which is 4n plus 3. This one right here, you plug it into g, which is 2n plus 1, or 2n plus 2. So I've taken the n part and I've opened it up and I've plugged in function h. And then I simplify. And I get 8n plus 6 plus 2, which is 8n plus 8. Now I'm going to take that function that I get. This is a g of h, 8n plus 8. Now I need to plug in my negative 3n. So I plug in my negative 3n where n is, and I get, again, negative 24n plus 8. So I get the same answer I got over here. So which one's easier? Well, it just depends. Depends on which one you prefer. In this case, I would prefer to do this method. This method seems easier to me in this situation. All right, so for question 14, what I did was I substituted in the negative 3x in for g first, and I got negative 6x minus 2, and then I took that function and plugged it into f. So negative 6x minus 2, when I plug that into f, this is x squared plus 1. So now I've got to take this function that I've created, this negative 6x minus 2, and that has to be squared plus 1. So I ran out of space, so I had to bring it back up here, because this now becomes negative 6x minus 2 times negative 6x minus 2 plus 1, because remember this was x squared. Then when I simplify this, I used FOIL, 36x squared plus 12x plus 12x plus 4 plus 1, and I got 36x squared plus 24x plus 5. And that is as simplified as I can make this. Now if I did it the other way, which is what I did here, if I did the function composition first, then I put the 2x minus 2, this function, into here first. So that's what I did here. And I get 2x minus 2 times 2x minus 2, which ends up being 4x squared minus 4x minus 4x plus 4 plus 1. So I get 4x squared minus 8x plus 5. And then I plugged in my negative 3x. So I did the function composition first, and then I'm plugging in my value for x. And so negative 3x into both of these gives me negative 12x plus 24x plus 5, the same thing I got over here. All right, in question 15, we have to find the inverse. So the function that we have is g of x equals negative 1/4 x plus 7/4. So we have some fractions here we have to deal with. So what I've done here is I've rewritten the function as, instead of writing g of x, I wrote y. Y equals a negative 1/4 x plus 7/4. Then I'm going to switch in order to get the inverse, which is what this means. G to the negative 1 power means g inverse. What I'm going to do to get that is I'm going to switch my x and my y. Those have to switch. So I'm switching x and y, and I get x equals negative 1/4 y plus 7/4. And now I'm going to solve for y. That means I need to get y by itself. So I'm going to subtract 7/4 from both sides of the equation. And I get this right here. X minus 7/4 equals negative 1/4 y. Now to finish isolating y, I need to multiply both sides by the reciprocal of this fraction. So remember, whenever you're dividing by a fraction, you're multiplying by the reciprocal. So we're just going to flip this number over and multiply. And we have to do that to both sides. So just remember, when you're multiplying this other side, you're multiplying both of these terms. So make sure you put a parentheses around those. Then we multiply through, we get negative 4 times x, negative 4x, and negative 4 times a negative 7/4. These 4's cancel, and you're just left with 7. But it's positive. Remember, negative times a negative is a positive. So we end up with plus 7. Of course, this negative 1/4 and this negative 4/1 goes away. And you're just left with y. That was the goal, was to isolate y. That's our inverse. So I'm going to rewrite it. G inverse x equals negative 4x plus 7. And this would be the inverse function of this function. Okay, now we're going to switch over to question 18. Okay, so a lot going on question 18. The first thing we had to do was find the inverse of each function. So we had to find the inverse of this function right here. So I rewrote this function as its inverse, which would be I'm switching x and y. So I switched x and y. I got x equals 1 plus 1/2 y. And now I need to isolate y. I subtracted 1 from both sides first. That gave me this x minus 1. That left me with x minus 1 equals 1/2 y. And then I multiplied by the reciprocal of 1/2 to get rid of that. So I'm continuing to isolate y. So I multiply both sides by 2. Now remember, when you multiply this side by this reciprocal, you have to put parentheses around this entire term, this entire expression that's on this side of the equal sign. So 2 times x is 2x, and 2 times a negative 1 is negative 2. And of course, now my y is isolated. So this is my inverse function. So I write f of inverse x equals 2x minus 2. Okay, so here's my inverse function, and I'm going to graph that. So first I need to graph this function, which I've graphed in black, which is this one right here. So my y-intercept was 1, and my slope was 1/2. So I graphed that line. I also graphed my line of reflection, which is this line right here. This is the y equals x line. That's my line of reflection. So let me write that in here, y equals x. Don't forget to graph that. You need to graph that so you can see the reflection. And then I graphed my inverse. My inverse had a y-intercept of negative 2 with a slope of 2. So here's my inverse graph. So my original graph, my line of reflection, and my inverse graph. Now these should be reflections of each other over the y equals x. And then the last thing it wanted us to do was find the solution for the graph of both functions, its intersection. So the intersection is always going to be a point where the lines cross, if there is a solution, on the y equals x line. So where all of these lines intersect each other is going to be your solution. So this solution is always going to be on your y equals x line. So that's how you can know for sure that you've got the right point. So our solution in this case is 2, 2. You can check your You can always check your solution by plugging that point back into both your original equation and your inverse function and check to see if it's true. All right, so question 19 is we're determining whether these given functions are inverses. And the way we're going to do that is we're going to do a function composition. All right, so I chose to do the function composition of f of h of x. And the reason why I chose that is because I just felt that it would be easier to plug in a negative 2x minus 1 into the other function instead of trying to plug in all these fractions. Either way it would work. You can do it the other way as well. If you want to try it that way, you can. I just felt that this one would be the easiest way to do this. So I've taken this function right here, this negative 1/2 x minus 1/2, and I've rewritten it right here. I opened up the x and I plugged in this negative 2x minus 1, which was my h of x, and I plugged that in. Then the next thing I did was simplify by distributing the negative 1/2. So negative 1/2 times a negative 2x gives me x, just x, because this negative 1/2 and this negative 2 cancel each other out. And then I also did a negative 1/2 times a negative 1, which is a positive 1/2. So that's how I got this positive 1/2. So when I simplify this, I get 1/2 minus 1/2, which is 0. So what I have is x. So when I do this function composition, if I get my variable back, then the answer to this question is yes, these two functions are inverses of each other. If I did not get this x back, if I got some other fraction or some other combination of terms, then the answer would be no. All right, for the next problem in question 21, the only thing we have to do here is state the domain and range in both set and interval notation. That's what this inequalities means right here. This is for set notation and interval notation, which is just with the parentheses or the brackets. All right, so for domain, I got negative 6 is less than x is less than or equal to 2. So my domain starts back here, 1, 2, 3, 4, 5, negative 6, but it's an open circle. So that means I'm not going to include it in my solution set. So that means that this is less than but not equal to x. Then on the right side of my graph, 1, 2, x goes all the way to 2. And in this case, the dot is closed, or it's equal to, so I'm going to have a less than or equal to notation for this end of my graph, and it ends at 2. So in interval notation, it's going to look like this. Open parentheses, because it's an open circle, -6, comma, and then closed parentheses at 2. So you notice that when we write domain, we go from the smallest number to the largest number, from the smallest number to the largest number. And we do the same thing for range. Range goes from the smallest number down here at the bottom to the top. So make sure that when you're writing range that you're going down first and then up to the top. All right, so for range we have -8 because that's our point down here. Now this point is closed. If we had an open circle here, then that point would be open, but that's not what we have. What we have is a closed point right here. This would be considered closed. So we have a -8 less than or equal to y less than 3. If I count up from here, 1, 2, 3, this is an open circle. So this is not going to be equal to when I'm doing set notation. So -8 less than or equal to y less than 3. For the interval notation, it's going to look like this. Closed bracket at -8 because this point is closed all the way to 3. This point is open with an open parenthesis. All right, for question 22, you need to understand what discrete and continuous mean. All right, we talked about this in class, but I'm going to emphasize it again. Discrete is individual points or individual values for either x or y, whereas continuous means that we've got some points that are connected. So connected, continuous, individual, discrete. So you'll notice here that these values for x are connected. They're connected between these 2 points. Between this point and this point, these values for x are connected. These values for x are connected. These values for x are connected. So this part of the graph, these x values, are continuous. So we would say that domain is continuous. But the y values, if you'll notice right here, this is only one value for y. This -3, this 1, and this 5. 1, 2, 3, 4, 5. That means that my y values are not connected. I don't have any connection between the y values right here. If you look in between here, there's no connection between these y values at all. So the y values in this case are the range, it would be discrete. Okay, so it could go the other way too. So just be careful on what graph you get on the test that you're looking to see, okay, which ones are connected? Are my x's connected or are my y's connected? And by the way, this is called a step function, and you're going to learn more about those probably in about a week and a half. Okay, in this graph for question 23, it says write the domain of the graph shown in interval notation. Well, in this graph, our x values, since we're writing domain, our x values go from -infinity, that's what this arrow means, from -infinity all the way to here. Well, this point is open, but this line goes straight up along 4. So that means that all of these values for x are 4. And so we have to include 4 for this graph as part of the domain, since all of these values for 4 are part of the domain. So I put an open parenthesis outside my -infinity, and then I include 4 as part of the domain in this graph. But what if the graph didn't go straight up? What if the graph went off to the right? That's going to change the domain. The domain now is going to be negative infinity to 4, but not including 4, because here the graph doesn't continue on along 4. It goes off to the side. So at this point of 4, the graph doesn't exist. It's open. So we have to leave that as an open parentheses. And then we have to do a union and then follow with the rest of where the rest of the graph is going. So this part of the domain would be to positive infinity. So from 4 to positive infinity, we also have a piece of graph. And so this would have an open parentheses as well. So the reason why we have this right here, we have to identify that at 4, there's no x value. So this is how we do that with our interval notation. Okay, so for question number 24, determine the domain and range of the inverse of the graph. The first thing I did was write down the domain and range of the original graph. And I know that all I need to do to find the domain and range of the inverse of this graph is to just switch domain and range. So I'm going to erase domain here and I'm going to write range. And I'm going to erase range and I'm going to write domain. And also I need to change my x's to y's and my y's to x's. And that's really all I need to do to find the domain and range of the inverse of this graph. That's it.